Okay, so 5.3 is definite integrals and antiderivatives. What the heck is that? Glad you asked. So this is what we've been working up towards for the last couple sections. Do you have the notes out? Are we okay? Yeah. We're at the top of page 14. Okay. So order of integration. You go from B to A. But if you switch it up, if you switch your bounds, you just have to put a negative in front, and then it'll be the exact same thing. So, for example, right? For example, if I'm taking an integral from 5 to 3 of f of x dx, this is going to be the exact same thing as if taking in the integral, let's see. Do you have a question? Yeah. Okay, just pay attention. Don't distract people. Yeah. I'm gonna send you away. Okay, I need you to pay attention. I'll literally have you move the desk. I'll move you away from people. Okay, because I'm sensing a common trend. Okay, so this is the same thing. If I switch the bounds, if I go from 3 to 5, f of x dx, you just put a negative in front, and then this is an equivalent statement. Okay, so we're good so far. If you switch your top and bottom bound, you just put a negative in front and we're good. This is just some like basic rules. It's kind of like the grammar of English. These are rules you must follow, but I'm not actually teaching you how to speak a sentence yet. I'm just telling you the rules. Whatever. 0. If you're going from A to A, wait, you have the exact same number on top and bottom. This is just going to be equal to 0. A constant multiple, so we kind of talked about this. Remember when we were taking limits, limit of a constant is just that constant. So if you're taking a taking an integral, and you have a constant, k is just our constant, you can rewrite it by putting the k just right out front. And this is for any number k. So, I feel like you guys will understand this, but I'll do an example. If I'm taking the integral from 0 to 2 of 3 times f of x dx, this is going to be the exact same thing as saying 3 times integral of 0 to 2 of f of x dx. You just bring the constant out front. We're good? We're good. Okay. The sum and difference. This is kind of like logarithms in a sense, right? Kind of, whatever. Actually, it's more like just function notation. If we are taking the integral and we're adding two functions, it's the same thing as taking the first integral, adding to the second integral. You have a question? Do you just draw a picture for him? Yeah. I see it in your hand. Okay, so just a reminder, your phone should be in the blue holder. You should be paying attention. Shouldn't be texting in class. Don't distract each other. If you throw gum, don't make a big deal out of it. Cool. It's all good. You can just steal her popcorn or whatever that is. You don't have to say anything. That's how I feel right now. Okay. Me-a-n. Got him. Okay. Sum and difference. So literally, you're just going to be taking the integral of the first one, adding it to the integral of the second one. Additivity. If you're taking an integral from a to b of a certain function, and then from b to c, so notice that these are the exact same numbers, the b, you can just take it from a to c, and it's the exact same thing. Well, this seems like I'm just talking to myself. Let's do an example. Yeah? Cool. So if the integral from -1 to 1 of f of x dx equals 5, and the integral from 1 to 4 of the same function is -2, and then the integral from -1 to 1 of h of x, a different function, is equal to 7, and then from -1 to 5 is 12. Wow, okay. Let's take a step back here. Use the rules of integration to find each integral. So the first one, we're going from 1 to 4 of f of x dx. Does anyone have an idea how I could solve this knowing some of the things that were listed up above? For instance, this one, we have the integral from 1 to 4. If only I had it from 4 to 1, how could I switch it? Any ideas? Noah?
Because it's the opposite of the 4 and 1.
So I could switch the bounds, the up and down, as long as I add a negative sign out front. So it's just going to be equal to negative times the integral from 1 to 4 of f of x dx. Well, that's exactly what we have up here. So it's just negative of negative 2, which is going to be a positive 2. Okay, let's try B. Going from negative 1 to 4. So look up above as soon as you're done. Maybe another 5 seconds or so. Discuss with a neighbor. How do you think you should solve this? Discuss with a neighbor next to you. How do you think you should solve B? Okay. So the thing I want you to want to call attention to is, notice we're going from negative 1 to 4, right? Well, I have the integral from negative 1 to 1, and then from 1 to 4. So if I'm going from negative 1 to 4, right, I just kind of like hook those together. It's like 2 puzzle pieces.
To add them, right?
Yeah, I just add them. So this is the same thing as saying the integral from negative 1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. So you just have to add them. This is just going to be 5 minus 2, which is 3. Shall we try C? Yeah? Or do you want more examples of the integration things up above? No? Okay, cool. Let's try C. So I am adding f of x plus g of x, f of x plus h of x, and then I'm taking the integral from negative 1 to 1. So remember, this is the exact same thing as saying the integral of negative 1 to 1 of f of x dx plus the integral from negative 1 to 1 of h of x dx. Do we know what each of these are? Yes, because they're defined up above, right? So take a look at this guy, and let's see, this one. See how there's the same thing? If I'm taking the integral, the addition of 2 functions is the same thing as taking the integral of the first plus the integral of the second function. So we're using the, which one is it? The sum of integrals. Okay, so we already know what these values will be. This will be 5 plus 7, which is just 12. So finding the rules of integrals, okay, and then I'll teach you actually how to find them. You have a question? No. No? Okay. What about D? What about D? Trying to take the integral from 0 to 1 of my first function. Well, I know what the integral would be from negative 1 to 1, but I don't know from 0 to 1. There's not enough info. Not necessarily. It may be half of it, it may not be. I don't know what this function looks like. Right, from negative 1 to 1, maybe the function looks like that or whatever. But if I'm trying to go from 0 to 1, it's only like this part of it. Like I don't know what the area would be unless I know what the actual function was. There's not enough info.
Really? You'll just throw a not enough info in there?
This is notes. Yeah. What's that face? It's all fine. Like, it's fine. We're going through the trick stuff in class. That way you don't miss it. Well, would you rather go through it now or by yourself?
Oh God.
Okay.
This is the first page of notes now.
What? No, this is like the 14th page.
Oh,
Oh, yeah. You're right. All right, let's try E. Let's try E. What do you think? Elliot?
I think that it's 5 to negative 1 minus 1 to negative.
So you read from the bottom to the top, but okay. That's all good. So I could rewrite this. I could break it up, and I could say the integral from 1 to 5 of h of x dx is going to be equal to, let's see, if I take from 5 to negative 1, right, I know what this is, of h of x dx, and I subtract the integral from negative 1 to 1 of h of x dx. Okay, so what this looks like, what this is going to be like, it's kind of like you have the whole area. Let me draw this. Okay, so like here's the function, whatever. Here's negative 1, 1, 5. And what we're trying to find is the area here. What you have is, you know, this section. And then what you also know is the whole area. I know, it's kind of messy. I'm sorry. Hold on, one more, come on.
It's like a puzzle.
Exactly. It's because you have this whole area. Let me move this down a sec. Okay. So you know the total area is this orange guy. And you know the area of the pink. So if you take the orange and minus the pink, you'll end up with the blue. Because you have the whole thing, right? The fourth one you have listed up here is the integral from negative 1 to 5. That is the total area. That is what the orange is showing. And then the blue, what we're trying to find is the blue. Well, we know the pink, we know the area from negative 1 to 1. So if I take the pink portion and subtract it away from the total, I'll have the blue, and that's why I'm wanting. I'm wanting from 1 to 5. Hopefully the visualization helps you, otherwise you can just stick with just the integrals. Okay, so you know the integral from negative 1 to 5. Right, the whole thing is going to be 12. And then you know the integral from negative 1 to 1. Right, this is just listed up above. This is 7, and then I'm subtracting them. So 12 minus 7 is 5. The total area of the blue portion is 5. So clearly, I did not draw my graph nicely. This doesn't make sense, right? It's got to be a different shape. Right, more likely what my graph looks like, okay, it has to be a lot of area. So maybe something like that. Between negative 1 and 1, it has to have 7. And then all over here, this is supposed to equal 5. That's more likely what our graph looks like. Has to be less area on the right side. Anyway, visualization, whatever. Hopefully it helps you understand what I'm trying to do here. Let's try F. Sorry, do we have questions? You okay? Just going to take some practice. Okay. Think about how you can rewrite this one. All right, turn to the partner next to you. Elliot, you can work. Okay. Elliot, you can turn around. Okay. So try to write out this one. Try it yourself. It doesn't make sense for me just standing up here doing it myself. Try to see how to write it. So turn to the person next to you. Spencer. Shani. You don't want to be with her? Rude. This is circle of friends. Come on, be with Shani.
Oh my god, that's the team.
Okay, Abby, Hannah, work together. Elliot, jump up and join them. Group of 3. Elliot, jump up and join them. Group of 3. No?
So it's just like the seed, mine's 3 times 5. That and that. So it's mine. 5 minus 7.
All right, who feels like they have a good grasp of how to do this problem? Who has a good grasp of this problem? Elliot, you want to come up and just point on the board and explain this? All right.
Elliot.
Yeah.
So, as you can see, these are the two things, and you know what both of these numbers are. This one's 5, and this one's 7. So it's 3 times 5, which is 15, minus 7, and it's 8, which is the answer.
Okay. So what's the very first thing you did? What's the first thing you did? What'd you notice first?
Well, that this, we know what this is, and we know what this is.
Very, very first line. I see.
The freak me move.
Yeah, I see the subtraction, right? The subtraction,
Okay, yeah.
you can break it up, subtract the first integral from the second. Then you see constant. I had a 3 in front of f of x. Derivative integral of a constant, you just move it out front. Cool, good. Now I just gotta list out. Let's see.
Me and Ty have to go.
Okay.
Why?
We have a baseball game.
Oh, good luck.
Good luck. You got this. So you know.
What? Wait, what?
Say good luck. You got this. You're like, I know.
No, I said right. He asked when do we actually have to leave, and I said right. And I said, thank you.
Yeah. Okay. All right. That's 8. Cool. Let me give you the worksheet before you go. Again. Definite integral. Okay. So I don't know why. Do you have to like watch this screencast? I don't know why some of the numbers don't pop up, but I emailed you the version and I uploaded it to my deck, so hopefully it'll show up there.
Okay, thanks.
You know how to print our space now. Okay,
Me too.
cool. Let's keep going. Questions on this one? We have, okay, that's one. We're trying to get through like 3 pages today. That's it. So we're good. It's 1 page down. So, section 6, what? We are doing, this is like where we're ending. This is day 2.
Oh, I don't have that.
What do you mean? You 100%. This is the notes.
Yes, you do, Spencer.
Yeah, you do. This is page 15.
Oh, it's 6.2, that's fine.
Yeah. Okay. So the way we teach the antiderivative, which is integral. It's okay. Ready? Pause. Ready? Everyone, look up. What is the derivative of sine?
Cosine.
Cosine. Guess what the antiderivative of cosine is? Sine. Ah, okay. You already know them.
Yeah.
Question is, which way are you going?
Smart.
A constant.
Right?
Huh? It's exactly reverse. The way I think about it, instead of going down, you go up. And as soon as we hit polynomials, you'll see why I have that like notation. Instead of going down, you go up. So 6.2.
Hard part that everyone talks about.
Yep. 100%. Okay, ready? Ready? We're focusing. We're focusing now. We need focus. You have sugar in your brain? We have focus now. Okay. So 6.2. It doesn't make sense to talk about definite integrals without talking about indefinite integrals. So an indefinite integral does not have defined endpoints. It's indefinite. It's not defined end. Okay. It's a family of antiderivatives, aka the opposite of taking a derivative. Instead of taking the slope to see how things change, you're trying to say, oh, the thing I'm looking at is the slope of the original function. Okay, so if the family of all the antiderivatives of the function f of x is the indefinite integral of f with respect to x and is denoted by f of x equals integral of f of x dx. Differentiation is taking a derivative, antiderivative. Antidifferentiation is an integral. Is that your question?
Antiderivative isn't an integral.
Antiderivative is the integral. And antiderivative is the integral.
An anti-integral is derivative.
Sure. Okay. If f is any function such that the derivative of f is f of x, okay, what this means. This right here, right? The derivative of an antiderivative is the original function. That's what this is saying. Derivative of an antiderivative is the original function. So, if the derivative of an antiderivative is the original function. Then if I take the integral, take the antiderivative of our original function, it's just going to be f of x plus c, right? Notice it's capital F. Where c is a constant called the constant of integration. Think about this. If I say f of x is equal to x squared, what is f prime of x? 2x. Okay, what about if I say f of x is equal to x squared plus 2? What is f prime of x? Ooh, so the issue is, ready? Let's do one more. F of x is equal to x squared plus 100. What is the derivative? 2x, again. So notice all of these have the exact same derivative, but but every 2x doesn't necessarily have the same antiderivative. So if my derivative is 2x, it's hard to know what the original function is. Notice that all of these had an x squared in common, but the difference is, what is the constant I'm adding? That's what this plus c is. Plus c is the constant I'm adding. So this, you have to figure it out based on initial value. If I say, oh, f of 1 is 1, cool, you plug that in and you can find out what the c would be. Because every time, what? Okay. So if you have x squared plus a number, it doesn't matter what number you're adding, the derivative will always be 2x. So if I start with 2x and I'm trying to take the antiderivative, aka taking the integral, I'm not just going to have one function, right? Because if the derivative is 2x, my original function could just be x squared. It could be x squared plus 1, x squared plus 100, x squared minus 50. Like, I don't know what the constant is I'm adding or subtracting. So that's where you have to have initial value. So what this means, ready for this magic? Magic time. Okay, so if f of x is equal to x squared, and we know f prime of x is 2x, what this means is if I take the integral of 2x dx, this is just going to be x squared plus c.
Plus c.
Where c is the constant. I don't know what my original function was. That's what I was trying to show you on the left side. Notice all of these functions are x squared. Right? X squared plus 0, x squared plus 2, x squared plus 100. When I take the derivative, they all are 2x as a derivative. But if I start with the derivative and I want the original function, there's an infinite number of functions where the derivative would be 2x. That's why we have a plus c, because it depends on our initial values to see which one of these is it actually going to be. So it's kind of tricky. It's a puzzle because there's all of these lots and lots of functions that all have the same derivative. Okay, so let's talk about some properties of indefinite integrals. Some of these are the exact same as what we've done before. So if I take a constant times a function, it's just going to be, if I have a constant inside, you bring the constant out. Okay, we've done that before. That's fine. These are just the rules we went over. If I'm taking an integral and I'm adding two functions, what you can do is just take integral the first plus integral the second. And then this is where the magic happens. The power formulas. Power formulas. Whew. Okay. So, remember, what? Remember, if I have something like x cubed plus 2x squared plus 5, what is the derivative? What do you do?
3x squared.
What do? You multiply in front, and then you subtract 1 to the exponent, right? Yeah. Multiply this in front, subtract 1 on the exponent. So we are going down an exponent when we take a derivative. Guess what happens when you take an antiderivative?
Go up.
You go up. This is why I think about it as going up and going down. Okay. Huh? It's fine. So if I'm taking the integral of, let's see, 2x to the first dx.
Does the integral sign basically
It's a stretched out s, more or less. It means sum.
but essentially is it like y prime?
No, not at all.
Like they're the equivalent?
Nope. Okay. So if I want to take the derivative, you would subtract 1 on the exponent and bring the exponent down. This time we're taking the antiderivative. So I want to add 1 to the exponent and divide by the number of my new exponent. So what this means is I add 1 to the exponent. What's 1 plus 1?
2.
And then, oh, that's the magic number, so I divide by 2. And then you have to add c, because that's your constant of integration. So this is just going to be x squared plus c. Anytime my derivative, are you paying attention? Do you have a question? Swear to God, you're going to miss what I'm going to say, and then you'll have a question, and I'll be angry because you're not paying attention. Do you have a question that pertains to this? No. We're going to say something else to her? Yes. You've got to pay attention. What I want you to do, move back, 1 spot, back, 1 spot over. Separation. Don't give me that face. I'll force you to learn. Okay. So notice that the indefinite integral, anytime you have 2x dx, right, you take the integral, it's always going to be x squared plus c. Now, if I say my initial values, when x was 0, y was 0, I could figure out what my c would be. Okay, I had to have initial value to figure out what c would be. To find out the constant integration, you have to have initial value. You have to have a point. Okay, so more or less you divide by the exponent. But of course, this is just for polynomial functions. If you have a negative in your exponent, let's say I have x to negative 1. We can't subtract. I don't want to add 1 because then it'll be to the 0 power. So if you remember, 1 over x is the derivative of what function?
ln.
Yeah. So if I'm taking the integral of ln is just going to be 1 over x. But notice it's going to be the absolute value. Oh my gosh. We're going to go through these, we're going to have more practice.
Wouldn't it, you have to go plus c?
Yes. You have to put a plus c. ln plus c. Sorry. This is, oh my god, I was going the wrong way. So if I am taking the derivative of ln, it's going to be 1 over x. Meaning, if I take the integral, take the anti-derivative, it's going to be ln of x. So this is just ln of x plus c. But notice, it might not just be ln of x. Maybe I'm going to take the integral of 1 over x plus 1. Okay, what this would be is, let's see, ln of x plus 1, and then whatever plus 1, whatever the derivative is there, plus c.
Okay. Why do we need a constant of integration when, it's supposed to be the antiderivative, but
Yes.
the c makes it non-antiderivative?
The c does. The c does. So you were here when I went over all of these functions. Is x squared the same thing as saying x squared plus 2? No, those are two different functions. X squared versus x squared plus 2. One looks like this, the other is up by 2. But the derivative for both of those functions are 2x. So if I don't give you the original function, if I just give you the derivative and I say, tell me what the original function was, the antiderivative, you're like, there's infinite number. Because all of these have the same derivative. That's the issue. Like this is plus 0, plus 2, plus 100. This is what our c is replacing. Because we might have a constant, we might have something we're adding to it, but we don't know yet. That's why we have to put a plus c. You have to put a plus c every time. And then if I give you some points, you can plug those in and see what the value would be of c. Okay, so if you think about it, what is the derivative of sine? Cosine. So if you take the antiderivative of cosine, you get sine. The derivative of tangent, secant squared. So if you take the antiderivative of secant squared, it's going to be tan. Do you see why it's not necessarily remembering something new? Because you already know these. It's just going backwards. Instead of going, oh, derivative of sine is cosine, you're like, wait, okay, integral cosine is sine. You're going the opposite direction. So, okay, if you know sine, cosine, secant, you can always figure out the others. I mean, I recommend knowing these. If you know the derivatives, you can figure out the integrals. Okay. So here comes Cha-Cha Man once again. Derivative of e to the x is e to the x. You try to take the integral, e to the x. Now the reason is because if you take this and take the derivative, oh, okay, that means the antiderivative has to be the same thing. What else do I want to say? Do I cover any more of these with you? This is the main one that you should know from this stack. What else do I want to say about this page? I wrote myself some notes, just a moment. What did I do? Let's see, what did I want to say? Okay, let's do a little more. Let's just do it on the side. So let's say y prime is 3x squared, right? What would my original function be? If I want to take the, what are some possible original functions? If this is what the derivative is, what are some possible functions for what our original would be? Noah? Yeah, x to the third. But I also could have x to the third minus 7. I could have x to the third plus 100. Now, the reason for that, I could have, let's see, one more. X to the third plus 1054. It's because when I take the integral of 3x squared dx, remember what we do? We add 1 to the exponent, right? 2 plus 1 is 3. And then you're going to divide the whole thing by your new exponent. So you divide by that same number. Instead of multiplying, instead of taking the exponent down and multiplying and subtracting 1 from your exponent, you add 1 to your exponent and divide by your new exponent. It's like the opposite direction. I don't know. I'm not being very good with verbs right now to describe how to do it. And you got to tack on a plus c. So this is just going to be x cubed plus c. This is the most simplest version we can have. Notice all of the ones I listed up above are x cubed plus a constant. I could be adding a constant -7, of 100, of 1054. They all are the exact same thing. What else do I want to say? Okay, did that example. Let's do one more. If I have something like f of x is equal to x to the 6. What is f prime of x? How do you take derivative? 6x to the 5th. Okay, so this means if I take the integral of 6x to the 5th dx, it's going to be x to the 6th plus c. Here, well, this is technically a plus 0, so our c would be 0 if I use that one. But all of my functions, all of my x to the 6 plus 5, x to the 6 plus 4, x to the 6 plus 100, all of those have the exact same derivative. Now, how we found this is you do, let's see, 6x to the 5th, and you add 1 on bottom and divide by the new number. So that's how we got x to the 6. Let's do some examples. So this will be the last page we go through today. Step by step, step by step. So don't forget, we're finding each indefinite integral. You have to put plus c at the end of every single one. You'll miss points this way. Please, don't forget to write it. Okay, let's go through. You guys want to try the first one yourself?
No.
Just kidding. Try it yourself first. Okay, so we're using the power rule. So I have x squared. You add 1, and that's 3, and so I'm going to divide the whole thing by 3. So this is just going to be 1/3 x cubed plus c.
Wait a minute, where'd you get the 3 from?
Because you add 1 to your exponent, 2 plus 1 is 3, then you got to divide by the number that's your new exponent. Yes. Notice, integral signs always have a differential associated with them, right? Integral with a d something. Let's try b. Integral of 2 cosine x dx. Okay. So remember, this is going to be the same thing as 2 times the integral of cosine x dx. Because it's a constant, right? Just move the constant out front. So if you think to yourself, okay, what function's derivative is cosine? Sine. Okay, so if I want the antiderivative, you go the opposite way. So instead of saying, cosine is the derivative of sine, you say, sine is the antiderivative of cosine. So it's just going to be 2 times sine of x plus c. You guys want to try out part C? Yeah, give it a shot. What is the integral of e to the x? So what function's derivative is e to the x? E to the x plus c. So really, derivatives are super important because when I'm solving integrals, I'm like, okay, which function's derivative is this? It's kind of like the way you solve logarithms. You always rewrite in exponential form. The way we solve integrals is you think about it in terms of derivatives. Okay.
Where do we use integrals?
All the time. Right, so you don't right now, but secretly your phone does. The lights, anything with computer chips, so your microwave. Yeah. The math. So it's kind of like asking, when do you use the word the in life? Like it's part of your English, right? It's part of your vocab. You use English to describe the world and like do work. Math is the language of science. You literally, so physics is applying, don't give me that face. A little snake flipping your tongue out. So, like, I don't even know where to begin with this because all of my classes in college used integrals and derivatives. So, you're gonna have to, like, you'll have to take, if you have to take calc in college, like, it will be better because you will have seen this at least once and you're like, oh, okay, cool. It'll be better. Well, I'm trying. Okay. Like, where do you use in life? Where's a good example? I don't even know where to begin. Everywhere?
How does a microwave use integral?
Okay, so here's, okay.
You know what? It's okay. Let's let it go.
So a microwave has a processor, has a little computer chip in it. How do you think when you touch buttons, literally something has to compute that symbol and like make it mean something? And so the like electricity that runs through there and the signal processing uses this. Like it's deep within, like it's literally integral to the computer chip. Yeah. Right. So where did I use this?
I'm gonna leave the integrals to the profession.
Like, but it's not just computer chips. Economics, macroeconomics, literally the intro economics class that my friends took in college, it's all integrals. Yeah, it's how you make good money. You don't have to know integrals, you just don't have to make good money. Okay, let's do D. You can make money other ways too, okay? Don't get me wrong. I'm just trying to give you an example where you use it. Okay, let's take it step by step. So, ready? Add 1 to the exponent. And now divide by 4. Subtract 1. Let's see. Add 1 to the exponent. Divide by my new number. Plus 8. Add 1 to the exponent 2 and then divide by 2. Add 1 to the exponent. Okay, so technically this is 4 times x to the 0.
No.
What? So I add 1 to the exponent, divide. So this is just going to be x to the 4th over 2 minus x to the 3rd plus 4x squared plus 4x plus c. Notice none of our antiderivatives have numbers, just numbers. Everything is like something with x, right? Notice I don't have plus 4. That's what the plus c is, right? You only have plus c if you have an indefinite integral because you're trying to find an equation, right? Your original equation. I give you the derivative, you spit back out the original equation. That's the idea. So I remember learning this. People either get it immediately or it's going to take some work. So it's fine. If it's got to take some work, it's all good. Most of you are seniors, so guess what? There will be a worksheet next week where it's literally practicing this.
You know our sub?
Yes, I do.
Mr. Levita?
I don't know.
You just said you know.
I do know. No.
Is it Mr. Levita?
Miss Co.
It's definitely. Oh no.
Let me see if she's available.
No. She is.
It's great. Let's keep going. No, everyone is a beautiful person and I love them all, but I don't want to tax them. I don't want to be like, can you cover my class, please? It makes me sad. No, he's in Israel. Okay, let's keep going. Let's keep going. How do I rewrite this? Oh my gosh. Oh my gosh. Okay.
It's cold in here.
This is the integral of 3 e to the x, right, plus integral of 2x to the 4. So all I'm doing, you don't have to do this every time. Hopefully you don't have to. But this first time, I want to show you how we figure it out. Okay. Integral of a constant. Okay, so I brought that out front. Constant, bring it out front. This is a lot of work. I'll show you in orange every single step, and then I'll show you in a different color the better way of doing it. 3 e to the x plus 2x to the 5th over 5 plus c. What you could do instead, you ready for this bombshell? So, okay, e to the x, I know it's just going to be e to the x for the antiderivative. So it's 3 e to the x. And then this is just a polynomial function. So you just add 1 to the exponent and divide by that number. You could go straight to this. That's fine. But the orange is showing you step by step the rules we're using. Pulling out a constant, right? E to the x. Antiderivative is just e to the x, and then the power rule. Yes.
For the c, will you ever get like when you take the derivative, the antiderivative of 3e to the x, you get 3e to the x. You don't have to tack on a c there. You only tack on a c at the very end.
Well, it's because I'm still adding them all.
So you won't get like 2c or 3c.
No, it's only just gonna be c. All right, let's do f. Good to move over. Okay.
Me?
No, me. Integral 6x minus square root dx. I'll just rewrite this a little differently. The same thing as saying integral of 6x minus x to the 1/2. It's a tricky one. Tricky trick. And then there's a dx over here. Tricky trick. So the first one's not too bad, right? So I have 6x, add 1 to the exponent, so that's a 2, divide by 2. Then the next one, if I add 1 to the exponent, I have x to the, what's 1 plus a half? 3 over 2. 1 plus a half is 1.5, 3 over 2. And then I'm dividing by 3.5. And then plus c. Gets a little hairy over here. So we got 3x squared minus, let's see, divide by 3 over 2 means multiplying by 2 over 3. So 2, let's see, top dog in the house, square root x cubed over 3 plus c. You could, you don't, okay. You could also, ready for this bombshell? Okay, you can just write it this way as well. 3x squared minus 2x to the 3 over 2 over 3. It's the same thing, whatever, it's the same thing. You don't have to put it in radical notation if you don't want, but you do have to simplify this portion down here. You see dividing by 3 over 2? No, you gotta simplify that out. All right, are we feeling a little better? Maybe? No, okay, that's fine. That's fine. This is why we broke it up into 2 days. Well, the idea was for you guys to have some separation so you don't talk. Okay, let's keep going.
More?
Yeah, is this not on your page? Yeah, we still have 4 problems. Okay, so how do I do it? What's the power rule?
X to the negative 3 over negative 3 plus C.
So you add 1, and then divide by.
Negative
Okay.
1.
So I'm going to add 1 and then divide by negative 1. So this is just going to be negative x to negative 1 plus c. Or, guess what? You could say negative 1 over x plus c. These are the exact same thing. Ah, all same thing. Okay. These are both fine. These are both fine. Try the next one. Hanafona. Yeah, let's go. Give it a shot. Give it a shot. Did your chili not keep you awake? Okay, keep going.
My Mexican casserole.
So, ooh, this is a hard one. So, okay. When I take the derivative of this thing, it's going to be negative sine x. Do we know what it is? Cosine.
Why are you like that? Oh my god.
No, because we had to learn that it's sine, cosine, negative.
But it would be negative cosine?
Oh yeah.
No.
Because, okay, so ready? When you take the derivative of sine, it's cosine, right? When you take the derivative of cosine,
It's negative sine.
it's negative sine. So taking the derivative, d dx, versus going this way, you're taking the integral. Does that my arrows make a little more sense? When you're going from cosine to negative sine, you took a derivative. When you go from negative sine to cosine, you take.
Like last year.
It was chapter 3. That's why I'm having a review worksheet of chapter 3. Yes, I'm going to make you 11 seniors work and do some stuff together.
Professor Levita.
Yes, he's my sub the whole week. Okay. It's going to be fine.
He's gonna help me with math.
I'm going to give him very specific directions.
Don't let him get anyone near the pizza.
No, it's called
Isolation.
I'm going to give him the worksheets of the day, and then you get them in class and he picks them up at the end, and you have to finish during the day, during the period. Like forced learning. That's what I like to call it. Forcing you to get better at math so you pass my class with a higher grade. Cool.
I need that.
Let's go on the next one. Tricky trick. What the heck do I do here? What function's derivative is e to the x? Ah, that's a nice chill. Okay. Ooh, okay. This is a little harder. So I'm going to add 1. Negative 2/3 plus 1 is 1/3, and then I have to divide by 1/3. So you add 1 to the exponent, and then take that exponent and divide by that number. And then plus c. Okay, if I'm dividing by a third, same thing as multiplying by reciprocal,
3.
which is 3. E to the x
This is easy.
plus 3 x to the 1/3 plus c. It's just practice. You've never seen this before. I don't want you guys to freeze. Right? This is fight, flight, or fear. Or what? Freeze, flight, fright, freeze. I don't want you to freeze. I want you to fight through it. 3 stages of anxiety. Okay.
About flight.
I said flight, fight, or freeze. The 3 steps of anxiety. Different people respond different ways. I was trying to avoid you freezing. I want you to fight through it, not run away either. Okay. This is the last example we'll do, and then I'll give you the worksheet. Okay. So let me rewrite this. This is just going to be 4 times the integral of x to 1/2. You've done something like this before. This isn't too bad. So if I add 1 to the exponent, I have 3 over 2, and then divide by that 3 over 2. Divide by 3 over 2. What? Multiply by 2, divide by 3. Yeah. So it's just going to be 8 times x to the 3 over 2 over 3 plus c. Okay. So these areas, that's fine. Did I go over this? Shoot, is this next time? Sure, it's fine. Okay. So I'll give this to you. I know some of the numbers kind of cut off, but I sent it to you in email and it's on my JAG. It should work.
This is due.
Brand new.
This is So there's a worksheet for today, a worksheet for tomorrow, that's the homework for tomorrow. Send a picture of me. Well, this is everybody's done this one.
Wait,
Or pass that down. Yeah, that sucks for you, honestly.
And she's giving me
Okay,
basically
so-
like, ask me how she can grade like easily.
So 11 through 20 are what we just did. 11 through 20, this page right here. 5 through 10 are what we started with today, and 1 through 4 are supposed to be review. Does that make sense? 1 through 4 are review. It's how you did it the last lesson.
Some of the numbers.
Right, so some of the numbers don't show up. I posted on my jag and I sent you an email. I don't know why I didn't print.
Oh, by the way, banana. I did watch the screencast. Banana.
Yeah, so it's saying like over, or saying like
That's funny.
different type of. You have the ones here where like, what you go on the shift, you went to different places and.
Yep.
Alright, so this is the.
The one for the quiz.
You were there. You didn't have to watch it.
Yeah.
She forgot she was here. Tall and Maya.
I think I thought.
Okay.
Hannah, there was more. You put the one that you colored on.
Still, that doesn't mean I
I'm
don't
gonna
want
ask
to
her,
use
'cause I have
them.
no clue what it means, like, so in general or in specific of like. So if it's Darwin, it's about, we have fully between Darwin.
Right.
Why is it literally so quiet right now? Like, today's been weird.
Are we allowed to skedaddle?